All right, let's talk about half-life. Half-life. So the half-life. Half-life is not just a video game. It's actually a term in science that lets us know how long will it take for something that's decaying to go down to half of what it started at. So it's kind of interesting because if something starts with like 100 grams of some sort of something that's decaying, it's going to take a certain amount of time to go down to 50 grams. Let's say that's 10 years. It takes 10 years to go to 50, but it's going to take another 10 years to go to 25. And another 10 years to go down to half of that, which is 2.5, etc., etc. It always will take the same amount of time to go down to half. Well, to go down to any amount. For whatever reason, they picked half as the number that they wanted to do it, but it takes the same amount of time to drop 10% and 10% and 10%. But the half-life is like how long will it take for a material or a substance to go down to half of what you started at. And that time will repeat itself no matter what number you start at. So when you get an equation like this one, P is equal to 100 half T5730. What does this mean? Okay, there's nothing at the back, so the 100 must be the starting point. That must be 100% likely. The half, well, this means that we're going to lose 50%. This half is what we're keeping, so we'll lose 50%. And that's a little confusing for other examples because this is the same amount that you lose that you keep. But remember that this was 80%, then that means that we lost 20%, okay? But because it's half, basically you keep 50, you lose 50. How often? Every 5,730 years. That's your half-life. That's your half-life. The number that goes under the T, because it's every how often. So I start with 100, I lose 50% every 5,730 years. So that 5,730 is actually the half-life for carbon-14. Carbon-14 is just the name of a substance that all living materials have inside of us, and is what scientists use to determine the age of like fossils. So they figure out, okay, how much carbon-14 is left into this fossil, and then they figure out, okay, so going backwards, this means this thing is like blah 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 years old. Okay, so that's kind of interesting that way. 5730 is not a number that you need to memorize, but it's used in the book quite a bit, but whatever. Okay, so how much carbon-14 remains after 5,000 years? So after 5,000 years, I can make a little bit of a guess, because it takes 5730 to go down to half. So in 50730, it's going to be 50. So it should be a little bit more than 50, because it didn't quite get that long. So let's try this. So P is equal to 100 times, I'm going to do 0.5, and then it's going to be 5,000 divided by 5730. Grab the calculator again. 100 bracket 0.5 bracket to the power of open bracket 5,000 divided by 5730. Enter. 5461. And that's kind of what we expected. It's got to be a little more than 50% because it would have taken longer to go down to 50. Make sense? Okay. So now here comes the part that's a little bit annoying. We'll change colors for this. So what if they ask us, how long will it take for the amount of carbon-14 to go down to 35%? So we want to say 35 is equal to 100 times 0.5 times something divided by 5730. And that gets quite annoying because there's no mathematical process that I know of. Yes, there is one, but we don't know it in grade 11, to figure this out. So we got to do trial and error. What do you mean trial and error? Well, I'm going to go 100.5 to the power of open bracket, and I'm going to guess. All right, so I know it's going to be more than 5,000 because that's 54, so it's going to be more than that. So maybe it's going to be 7,000 years. I don't know. I actually do not know. 7,000 divided by 5730, close bracket, enter, and I got 42. So I still have too much. So I need more time to go by for it to work. So I'm going to try 9,000 years. 9,000 years. I changed the 7 to 9. Hit enter. And that's 33. Okay, I'm getting really close. I want 35. So I went too far because now there's too little. So I need to go back in time a little bit. So I'm going to try, I don't know, 800 years. Hit enter. 34, 4. So it's still too little. So I'm going to try 85. Well, I'm getting really close. 35.7. So I'm going to try 84. Wait, did I go the wrong way? Yes, I went the wrong way. So see, I wasn't thinking. So let's try 85.50. 35.5. Let's get really close. So 85.8. I'm getting close. Oh, 86. Maybe it's 86. 35.3. So probably 8 and 6. I'm going to try one more. Just to, while I have you here. That's pretty good. So when it's 85, oh, when it's 85, no, 86.50, I get a number that's 35.12. So that's pretty darn close. So by doing a little bit of trial and error, we found out that after 86.50 years, the material goes down to 35.12. Good?